Okay, this is a short video on simple series and parallel circuits. Okay, these two circuits are connected differently. This one is connected such that the current that is produced by the battery goes through each resistor. So the same current that goes through the 40 ohm resistor will also go through the 20 ohm resistor. There's nowhere to go. So same current in the loop. Now, this one is parallel circuit. It has two loops. When the current produced by the battery goes to this junction, there's two ways it can go. So one part of it will go through the 40 ohm resistor and another part will go through the 20 ohm resistor. Okay, it will split, just like when you come to any junction. So part of the current will go one way and part will go the other way. It's like this, if you look down here. So here, any current that goes through the first resistor will also go through the second resistor. But when it comes to this junction, it will have to split. So think of parallel as the current that splits. When the current splits, you have parallel circuit. When it's the same current going through all the resistors, you have series circuit. So here's the definition. For series, the same current going through both resistors. Okay? Different voltage drops across each resistor, depending on how big the resistance is. So here is 40 ohm, is bigger than 20 ohm. That means there's bigger voltage drop. Okay? So whatever this voltage drop is, will be bigger than this voltage drop across the 20 ohm resistor. And when you add them together, this V1 plus V2, it will be 10 volts. 10 volts. Okay? So that is the voltage drop. So it depends on the size of the resistance. Bigger resistance will have bigger voltage drop. So let's say here is 10 volts, 10 volts, 10 volts right here, and then it will drop. I don't know, let's say it drops 6 volts. So it will drop to 4 volts, and then from 4 to 0. This will be 0, 0, 0, 0. So this point will be 4 volts, that point of potential. Okay, now this one, the current splits. The current splits. Now, larger current will go through the smaller resistor. Remember, resistor resists. So they resist the voltage. Okay? So they take out some of the energy from the system. So the current likes the path of least resistance. So lower resistance will have more current. Higher resistance will have less current. Okay? So, but the voltage drop will be the same. Same voltage drop across each resistor. Because if you connect this junction together, these two is the same junction actually. So here, so you can connect these two wires together. So you get one node, right? Just like right here. So same. So there has to be one potential difference here and between here and here. So same point, same point. So this is 10 volts right here, 10 volts, 10 volts. When you go across the 40 ohm, it becomes 0 volt, 0 volt, 0, 0, 0, 0. When you go across 20 ohm resistor here, it becomes 0 again, 0. So this 10, 10, 10, 10, 10, 10 up here, and then 0 down here. So when you go across each resistor, the potential drop is 10. Okay, so 10 volts. Okay, so same voltage drop for parallel, same current for series. Okay, so let's look at some example here. Current comes in. Okay, so this is series because it's same current. So this current will be equal to this current that go through these two resistors. They must be equal. There's nowhere else to go. Now, when it comes to this junction, the current splits. So when they split, think of parallel. Parallel means splitting, right? Splitting current. So part of it will go up, part of it will go down. So it depends on the resistance. If down here is larger resistance than up here, so this will be smaller current. Smaller current. So larger resistance. There's more resistance. That means there's less current. Current doesn't like resistance, remember? Okay? So now, this is in series because it's same current going through both resistors in series. Now, there's different voltage drop for this. Different voltage drop. So depend. If this is bigger resistor, it will have bigger voltage drop. If this is smaller resistor, it will have smaller voltage drop. But in the case, the voltage drop across these two resistors will be equal to the voltage drop across this one resistor down here, because these two nodes, these two wires are the same. Okay, same node. Okay, so now how to find equivalent resistance? Combine the series first. Okay, so look at this. Combine the series. Start from furthest away from the power source. Power source is right here. Start from right here. Okay, start from the 40 right there. But you cannot do anything with 40. You just know that 40 is in parallel with 10 and 30. Now 10 and 30, this is in series. So you combine them, you get 40 right here. And then you have parallel right here, 40 parallel to 40. Okay, remember, why is it parallel? Because when the current comes in here, it splits. Part of it go there, part of it go there. Okay, it splits. Splits is parallel. So 40 in parallel with this. Okay, 10 and 30 are in series because it's the same current going through. Okay, so 40 in parallel with 40. Use that formula. Equivalent resistance, 40 times 40 divided by 40 plus 40, you get 20. Okay, so you get 20 for this. So 20. Now this 20 ohm is in series with 25 ohm right here. It's in series. So you just add them together, 20 plus 25. So you get R equivalent is equal to 45 ohm. Okay, so done for that one. Okay, so for series, that's the formula for series. For parallel, okay, this times this divided by this plus this for parallel. Okay, I just do 2 resistors at a time. You can always do 2. You don't have to do like 4 at a time. So just pick 2 and combine them, and pick another 2, combine them, and then use this formula. The product over the sum. Okay, and that's it.